About 56 million years ago, a massive release of greenhouse gases, likely triggered by volcanic activity, caused a period of extreme global warming, known as the Paleocene-Eocene thermal maximum, PETM for short. A new study by researchers from the University of California, Santa Cruz now confirms that the PETM was preceded by a smaller episode of warming and ocean acidification caused by a shorter burst of carbon emissions. These new findings indicate that the amount of carbon released into the atmosphere during this precursor event was about the same as the current cumulative carbon emissions from the burning of fossil fuels and other human activities. As a result, the short-lived precursor event represents what might happen if current emissions can be shut down quickly, while the much more extreme global warming of the PETM shows the consequences of continuing to release carbon into the atmosphere at the current rate. The paper co-authors 𝙁𝙤𝙡𝙡𝙬 and 𝙁𝙤𝙡𝙬 say it was a short-lived burp of carbon equivalent to what we've already released from anthropogenic emissions. If we turned off emissions today, that carbon would eventually get mixed into the deep sea and its signal would disappear because the deep sea reservoir is so huge. This process would take hundreds of years, a long time by human standards, but short compared to the tens of thousands of years it took for Earth's climate system to recover from the more extreme PETM. The new findings are based on an analysis of marine sediments that were deposited in shallow waters along the US Atlantic coast and are now part of the Atlantic coastal plain. At the time of the PETM, sea levels were higher and much of Maryland, Delaware and New Jersey were underwater. The US Geological Survey has drilled sediment cores from this region, which the researchers used for the study. The PETM is marked in marine sediments by a major shift in carbon isotope composition and other evidence of dramatic changes in ocean chemistry as a result of the ocean absorbing large amounts of carbon dioxide from the atmosphere. The marine sediments contained the microscopic shells of tiny sea creatures called foraminifera that lived in the surface waters of the ocean. The chemical composition of these shells records the environmental conditions in which they formed and reveals evidence of warmer surface water temperatures and ocean acidification. First author Babila said previously thousands of foraminifera fossil shells were needed for boron isotope measurement. Now we are able to analyze a single shell that's only the size of a grain of sand. Evidence of a precursor warming event had been identified previously in sediments from the continental section at Bighorn Basin in Wyoming and a few other sites. Whether it was a global signal remained unclear, however, as it was absent from deep sea sediment cores. 𝙁𝙤𝙡𝙡𝙬 said this makes sense because sedimentation rates in the deep ocean are slow and the signal from a short-lived event would be lost due to mixing of sediments by bottom-dwelling marine life. The best hope for seeing the signal would be in shallow marine basins where sedimentation rates are higher, he said. The problem there is that deposition is episodic and erosion is more likely, so there is not a high likelihood of capturing it. The USGS and others have drilled numerous sediment cores or sections along the Atlantic coastal plain. The researchers found that the PETM is present in all of those sections, and several also captured the precursor event. Two sections from Maryland at South Dover Bridge and Cambridge Dover Airport are the focus of the new study. Here we have the full signal, and a couple of other locations capture part of it. We believe it's the same event they found in Bighorn Basin, 𝙁𝙤𝙡𝙡𝙬 said. Based on their analysis, the team concluded that the precursor signal in the Maryland sections represents a global event that probably lasted for a few centuries or possibly several millennia at most. The two carbon pulses, the short-lived precursor and the much larger and more prolonged carbon emissions that drove the PETM, led to profoundly different mechanisms and timescales for the recovery of the Earth's carbon cycle and climate system. The carbon absorbed by the surface waters during the precursor event got mixed into the deep ocean within 1,000 years or so. The carbon emissions during the PETM, however, exceeded the buffering capacity of the ocean, and removal of the excess carbon depended on much slower processes, such as the weathering of silicate rocks over tens of thousands of years. 𝙁𝙤𝙡𝙡𝙬 noted that there are important differences between Earth's climate system today and during the Paleocene, notably the presence of polar ice sheets today, which increase the sensitivity of the climate to greenhouse warming. Speaking of greenhouse gas emissions, new research by National Renewable Energy Laboratory US and Xerox PARC shows that controlling humidity on GHG emissions can have a large impact on the environment. Greenhouse gas emissions from air conditioners are expected to climb as economic growth drives efforts to control both temperature and humidity, while the energy used to power air conditioners has clear implications for greenhouse gas emissions. The impact of removing moisture from the air has escaped in-depth study until now. The researchers showed that controlling humidity is responsible for roughly half of the energy-related emissions, with the other half due to controlling temperature. It's a challenging problem that people haven't solved since air conditioners became commonplaces more than a half-century ago, said Woods, a co-author of the new study. The researchers pointed out that the increasing need to cool the air is both a cause and an effect of climate change. Even a small amount of moisture in the air can cause people to feel uncomfortable and even damage buildings in the form of mold and mildew. Furthermore, controlling indoor humidity through commercially available air conditioning technologies impacts the environment in three ways. First, they consume a considerable amount of electricity. Second, they use and leak CFC-based refrigerants with global warming potential that is 2000 times as potent as carbon dioxide. And third, the manufacturing and delivery of these systems also release greenhouse gases. The researchers calculated air conditioning is responsible for the equivalent of 1950 million tons of carbon dioxide released annually, or 3.94% of global greenhouse gas emissions. Of that figure, 531 million tons come from the energy expended to control the temperature and 599 million tons from removing humidity. The balance of the 1950 million tons of carbon dioxide comes from leakage of global warming causing refrigerants and emissions during the manufacturing and transport of the air conditioning equipment. Managing humidity with air conditioners contributes more to climate change than controlling temperature does. The problem is expected to worsen as consumers in more countries, particularly in India, China and Indonesia, rapidly install many more air conditioners. It's a good and a bad thing, Woods said. It's good that more people can benefit from improved comfort, but it also means a lot more energy is used and carbon emissions are increased. To calculate the emissions to manage both temperature and humidity, the researchers divided the globe into a fine grid, measuring 1 degree of latitude by 1 degree of longitude. Within each grid cell, the following characteristics were considered: population, gross domestic product, estimated air conditioner ownership per capita, the carbon intensity of the grid, and hourly weather. They ran nearly 27,000 simulations across the globe for representative commercial and residential buildings. Climate change is affecting ambient temperatures and humidity around the globe, making it warmer and more humid. As part of the study, the researchers considered the impact of changing climate on air conditioner energy use by 2050. For example, the study projects air conditioner energy use to increase by 14% in the hottest climate studied, Chennai, India, and by 41% in the mildest Milan, Italy by 2050. The increase in global humidity is projected to have a larger impact on emissions than the increase in global temperatures. We've already made the existing century-old technology nearly as efficient as possible. To get a transformational change in efficiency, we need to look at different approaches without the limitations of the existing one, Woods said. Existing vapor compression technology is optimized to cool our buildings using a vapor compression cycle. This cycle uses harmful refrigerants to cool air down low enough to wring out its moisture, often overcooling the air and wasting energy. Improving the vapor compression cycle is reaching practical and theoretical limits, thus pointing to a need to leapfrog to an entirely new way to cool and dehumidify buildings. New technologies that split this cooling and humidity control problem into two processes show the potential to improve efficiency by 40% or more. One such technology space is the use of liquid desiccant-based cooling cycles, such as the many liquid desiccant air conditioning technologies that NREL is currently developing with many partners such as Emerson and Blue Frontier. The researchers point out that the use of liquid desiccants fundamentally changes the way humidity is controlled and has a theoretical efficiency limit that is 10 times higher than the vapor compression cycle alone. A hypothetical technology at only half of this new limit would reduce cooling energy emissions by 42% in 2050, with the equivalent of avoiding 2,460 million tons of carbon dioxide annually. Meanwhile, new research by American Geophysical Union shows that as the atmosphere and ocean warm, marine cold spells are becoming less intense and less frequent overall. Marine cold spells are cold versions of heat waves, periods of exceptionally cold water, able to hurt or help the ecosystem they hit. Today, the oceans experience just 25% of the number of cold spell days they did in 1980s, and cold spells are about 15% less intense. Researchers found weaker cold spells could mean they're less likely to cause mass die-off events, but having fewer cold spells also mean refugees and recovery periods from marine heat waves are disappearing. It is the first study to quantify and compare the changing nature of marine heat waves and cold spells over several recent decades on an ocean-wide global scale. The lead author Wang says, because marine cold spells have both positive and negative impacts, understanding when, where and why these spells occur is critical for predicting their presence in the future. Predicting cold spells could be important for fisheries long-term planning and for ensuring catch limits are sustainable. 𝙨𝙗𝙗𝙧𝙩, a physical oceanographer not involved in the study, says extreme events, either warm or cold, can bring an ecosystem to the edge, establishing the ocean's baseline climatology and sensitivity of heat waves and cold spells to temperature changes like they did in this study is a burning question for the community. Marine heat waves, like heat waves over land, are natural phenomena, becoming more frequent and intense in some places as a result of anthropogenic climate change. Similarly, marine cold spells are natural, but their rates are changing around the world. Over the past decade, cold spells have occurred roughly 10 days per year globally, a notable drop from about 40 days per year in 1985. To understand when and where marine cold spells occur and how those patterns have changed over time, Wang and her colleagues analyzed sea surface temperature data from 1982 to 2020, checking for periods of either extremely hot or cold temperatures. They found the oceans are warming, corresponding to global warming trends, and sea surface temperatures are becoming variable over time. That variability leads marine heat waves and cold spell intensities to change at different rates, complicating scientists' attempts to predict each. Establishing global trends in marine cold spells and their relationship to global warming is an important step, but further studies are needed to constrain regional and local effects, Wang said. Those local effects include impact on fisheries, which can be positive or negative. She further added, marine cold spells play dual roles in influencing ecosystems. They can cause devastating impacts like coral bleaching and mass mortality events, but cold spells can offset the impacts of heat waves. While 𝙨𝙗𝙗𝙧𝙩 say extreme events affect coastal communities and economies, but members of the public might not be aware of how they're going to intensify in the future. We need to get the word out. Information about the underlying physical causes of these extreme events can help improve forecasting, which can lead to the development of early warning systems. That information can be provided to fisheries and other stakeholders, and they can collaborate on the best adaptations, the best path forward. The better communities know what to expect, the better they can prepare. Well, how researchers have created a novel technology inspired by nature to measure humidity and how pollution can be turned into cash? We'll leave that for the next video. Until then, do give us your thoughts on this environmental report in the comments.